This is so big, it barely fits under the camera. It is a light from Lidl. It's designed for mounting under kitchen worktops, things like that. And it comes with a cable going in at one end, a pluggable cable going in at one end. Let me unplug it. But it doesn't let you extend out the other end to extend them onwards. But anyway, when you turn it on, it projects light downwards. The colour it's not cold white, it's a sort of medium white, it's not too bad. But anyway, let's open it up and see what's inside. So I shall unplug it first. I feel the need to say that now, the way things are going. I'm guessing this bit will slide out. It also comes with little clamps that you screw them onto the surface and then they sort of slide in. I'm not sure how that works, not tried it. I probably won't be screwing it onto the surface. I did almost consider using this as part of the studio lighting here, but it wasn't practical. This is not a great place to film, but that's fine. We've got our, well, we're in the second last day of the show today. And then we've got a few days load out. Is this going to, oh, it's going to slide out. Oh, it's one circuit board. Oh, that's interesting. So yeah, we've got three shows left, one today and two tomorrow. And then it's the load out of the show. Right, this is a clip. Does this clip come out? Oh, yes. What's that? Oh, it's glue. Oh, it's a one-way trip. Okay. It's going to have a capacitor on it. Oh, there is a capacitor. Well, let's bridge the capacitor just to make sure it's discharged. I completely failed to bridge the capacitor. And the thing has been heat staked onto these. Are these part of the front? I don't think that's going to come out as such, because I think everything's been put in. It might even be the strip that's actually holding those in. I'm not really sure. Right, tell you what, I shall cut these heat stakes off because we want to see what's on the other side of this. Oh, this is straightforward. I shall zoom down a bit so you can see better. So just cutting the heat staked pins off so we can take the circuit board off using a little bit of unreasonable force. I'm wondering if this is a linear regulator, because the construction of this, it has the capacitor tucked into a little connector there. It is. Right, okay. So, do these come out? Are these clipped in? Right, okay. Oh, it's going to have to lift up the way. Right, okay. And then the lens pops out. So the lens pops out the front, this clips in the back, and then gets heat staked onto the circuit board. And I think that's what literally holds it together. Is that capacitor on a charge? I'll just short that out. Make sure I'm still in a shot here. Right, tell you what, we kind of know what the circuitry is. But I shall take a picture of this here of the circuit board and we can explore it. One moment, please. Reverse engineering is complete. Let's explore. And if you've not already worked it out, it's basically speaking an LED bulb like this spread across 4 separate points to make it look like 4 separate lights. And it's very clever the way it goes together. You've got this bezel with a snap-in diffuser, well, a clip-in, it just lays in really, diffuser. But this actually physically clips into the housing. The diffuser's put in, and then when you sandwich this on top, it not only acts as a reflector, but it also actually clamps it into the housing, and that is locked in place by the circuit board being put on here, these pins being heat staked, and that gives you the effect of a cluster of 4 multi-chip LEDs behind that bezel with the diffuser. Very neat. It also means, I'm going to zoom down a bit here, it also means that when one of the chips, because these are multi-chip LEDs, when one of the chips in these LEDs fails, the whole fitting fails, and suddenly this big piece of aluminium extrusion and this steel backplate and the aluminium circuit board inside, which is a fairly thick piece of aluminium, it all goes to landfill for that one failed LED. There's nothing the eco-warriors love more than cash. Anyway, moving on. The circuit board looks like this. Let me just make sure this is well focused in. There's a bit of reflection, a bit of glare at the end. That's just because of where I am. If we take a look at this, we can see, let's actually just tame this down. Oh, that did not tame that down. Let's focus to there. That's kind of better. Yeah, we'll go there. Right. It's a bit harsh. That's okay. The incoming supply has these. That's a silverfish. Lots of silverfish in this place. The incoming supply has two push-in connections. These push-in connections, the wire has been tinned and then it's been pushed in and it basically locks into a sort of springy contact. So that's what's happening in here. There is a 10 ohm resistor, brown, black, black, 1, 0, and 0 as a decimal multiplier, so it's 10 ohm, and that acts not just as an inrush current limiter, but also a fusible resistor. Not that inrush limiter is totally needed, because this chip here limits the current into the capacitor. This little cream coloured housing here is actually what the capacitor is pushed through. I took the capacitor off and I just sat it in the front, so you could see it's a 6.8 megafarad 400 volt capacitor. So the incoming supply via that resistor goes to a bridge rectifier and then goes via a diode, a high-speed diode, to effectively give them the illusion that this is a whole rectifier made of high-speed diodes, presumably. It goes to this fancy chip, and I'll show you the schematic of that shortly. Notable things, it's got a couple of support components, a 1 mega ohm resistor, which is odd, a capacitor, and then two current sense resistors, 39 ohm and 43 ohm, to fine tune the value of the current through the LEDs. It's got a link here just to jump over a track, and then it's got a 1 mega ohm resistor across the capacitor to make sure that there's a slight load, and also to make sure that when you turn it off it goes out decisively. Let me show you the schematic. There is a number in this chip. That's handy. But it doesn't pull up much in the way of a data sheet, which is a bit disappointing. So here is the 10 ohm resistor. 10 ohm. There's the bridge rectifier. There's the high-speed diode. And this capacitor, this is the electrolytic capacitor here, and it doesn't just charge directly across the output. There is a current limited supply that charges that capacitor up. And what that does is, instead of the capacitor just taking its full charge at the peak of the main cycle, because the current's being limited into it, basically it covers a larger part of the sine wave that it's charging up, but it will never fully charge up theoretically to the peak mains voltage like the normal arrangement would be. There's the 1 mega ohm discharge resistor. There's the chain of 16 multi-chip LEDs. I would guess maybe 12 chips per LED, not really sure. Then we've got a little capacitor here. Now it says comp, that could mean compensation or comparator. Then it's got PF and that 1 mega ohm resistor. I think that's a 1 mega ohm resistor. I could check that right now. Is it a 1 mega ohm resistor? Bring in the meter, let's find out. So I'll put this round to resistance, and this may have other circuitry in line with that. Is it going to read? It says 169k round one way and 326k round the other way. So there's internal circuitry that's skewing that. So that's not a great answer. But I would think it is 1 mega ohm resistor. And then there's the two parallel resistors that they use to in parallel to fine tune the value. Now this is one of these things that if you wanted to make this last longer, you could theoretically remove one of these resistors, but to do so, you have to cut all the heat stakes and remove the circuit board, and nothing will ever be quite the same after that. Oh, another thing worth mentioning, if you look at where these wires come on, the live and neutral, as well as just pushing in there, they've also put a blob of silicone sealant, and that is just to make sure that they don't pop out, because if they did, they could touch the case, and this is not a grounded case. It's classed as a sort of double insulated device, which is debatable, but that's what they do. But that's it. It's an interesting thing. It's quite clever the way it goes together. It's a fairly neat and visual effect. It is cheap because of the mass production. But like all these things, you know, I'm not sure how long it's going to last. At least it's got a bit of heat flow. I mean, this aluminium heat sink with the LEDs in it, I cut it a bit. I cut it to take it into work, by the way, and get a picture taken of it. It's not directly coupled thermally onto this outer metal case, so it's a sort of radiative, sort of thermal convection type coupling, which isn't ideal, so that will get quite hot inside. But nonetheless, It's an interesting light, even if it does seem quite wasteful that it's been, this is just landfill. But that's how modern LED lights are. They're not quite as eco as they say. But that's it. It's a neat construction, very much optimized for mass production. Quite clever.